Welcome to Chapter 6 of the Node.js High Performance course. This chapter is titled Test, Benchmark, and Analyze, and we're going to begin with the most fundamental question: why do we test our code at all? Testing is not just about catching bugs after they happen. It's about building confidence in your codebase as it grows and changes over time. The most common starting point is unit testing, a method by which parts of your application are individually checked to confirm that they comply with their specifications. Unit tests encourage your application parts to act as independent and replaceable black boxes. Now here's something that surprises many developers: you need both realistic and unrealistic data in your tests. Real data confirms that the happy path works. But unrealistic data, text in number fields, null values, missing properties, confirms that your application won't break when misguided or even malicious users interact with it. Think about it: does your application handle text in date fields? Numbers in checkboxes? Missing required fields? If you have more than one developer working on the codebase, you want to be absolutely sure those edge cases stay handled, because the most common type of bug appears in one place after making a change in a completely different place. The goal of unit testing is to completely isolate each module and test it independently. If a module depends on a database or another service, you can fake that data or mock the dependency. Tools like Sinon.js at sinonjs.org make this straightforward. Let's talk about the concrete benefits. First, bugs are found early in the development cycle. Every time you change your code, your tests run, and bugs are spotted immediately, long before they reach production. The cost of fixing a bug in development is a fraction of what it costs to fix it in production. Second, tests force you to think about input and output data and error scenarios. Every feature and use case is developed with test cases in mind, which leads to more thoughtful architecture. Third, tests enable safe refactoring. You can restructure your internals while ensuring the external behavior stays correct. Fourth, unit tests facilitate integration testing, because once each module has known, verified behavior, combining them becomes much more predictable. Remember, all these benefits only materialize if your tests are properly defined and cover the entire application, all functions and all objects. Now that we understand why testing matters, let's look at the three major categories of tests you'll write in a Node.js application: unit tests, integration tests, and acceptance tests. Unit tests are the foundation. They test a single module or function in complete isolation. If a module needs a database, you mock it. If it needs an HTTP call, you stub it. This isolation is what makes unit tests fast and reliable. They don't depend on external systems, so they can run in milliseconds and give you immediate feedback. The trade-off is that you need to invest time in writing good mocks and stubs. Integration tests are the next level up. They test how multiple modules work together. For example, you might test that your data access layer correctly talks to a real database, or that your authentication middleware correctly works with your route handlers. Integration tests are slower than unit tests because they involve real system interactions, but they catch a whole class of bugs that unit tests miss: the bugs that live in the communication between components. Acceptance tests sit at the top of the pyramid. These test the entire application from the user's perspective, sometimes called end-to-end tests. They simulate real user workflows: log in, create a resource, read it back, delete it. They're the slowest and most expensive to run, but they give you the highest confidence that the system works as a whole. Here's an important subtlety about separation: if one of your modules needs a database to function, and you give it real database access in your test, your unit test has actually become an integration test. And if that test fails, you can't tell whether the problem is with your module logic or with the database connection. This ambiguity is precisely what you want to avoid by keeping unit tests truly isolated. The practical approach is to run your unit tests constantly during development. They should run in seconds. Run integration tests before every commit. Run acceptance tests before every release or deployment. Each layer of the test pyramid gives you different, complementary confidence about your system. Let's get hands-on with Mocha, the test framework recommended in this book. Mocha is available on NPM, and you should install it globally so you can use it across all your projects without declaring it as a runtime dependency. To install Mocha globally, run sudo npm install gmocha. This also puts the Mocha command on your system path, so you can run it directly from your terminal. Here's the workflow. You have a module, let's say module.js, that exports an add function. Exports.add equals a function that takes a and b and returns a plus b is simple. Now you create a test file, test.js, that loads the assert module in your module, then uses Mocha's describe and it functions to structure your tests. The describe block names the thing you're testing, and each id block describes a specific behavior it should exhibit. When you run Mocha in the directory with these two files, it auto-discovers test files, runs them, and shows you results using a reporter. The default is the spec reporter, which shows a hierarchical view of your test suite with green check marks for passing tests and red X marks for failures. Now here's where it gets interesting from a performance perspective. Let's add a second test. It should return null when one of the inputs is not a number. We assert that m.add2a should equal null. Run Mocha again, it fails. Good. That's test-driven development in action. Now we go fix our module, add an isNaN check at the top that returns null if either input is not a number. Run Mocha again, both tests pass. Mocha also supports different reporters for different contexts. The progress reporter gives a minimal dot matrix output good for large test suites. The list reporter prints each test on a line. The spec reporter, which you saw, gives full hierarchy. Choose the reporter that fits your CI environment and your team's preferences. The key insight for performance work is this: Mocha has a default timeout of 2000 milliseconds per test. This is your first built-in performance gate. Any test that takes longer than 2 seconds automatically fails. You can override this globally or per described block with this .timeout, and you'll use this to set tight performance budgets on your most critical operations.